about 3D printing is nothing bad.
It's the build-up. It's the build-up that got us there.
So how many of you?
It's just your present.
Well, yeah.
So how many of you have? Thank you.
Because that's just
Have
showing
3D
so much
printers?
growth.
Raise your hands. Okay, so about half of you don't, which is good, which means I can teach you some new things.
I know somebody wants to sell theirs. Thank you, Rick.
You have to tell me why you want to sell.
Not me, it's somebody else.
Okay. Yeah, so for the new people, this talk is going to be about, all the way from the basics to some more, getting started things. But for people that have 3D printers, you might get a couple pieces of information that might help you with it too. Most of you know me, and those that don't will probably know me too. But I've been with the Christmas light hobby for about 10 years. And I've been, started way back with before X Lights. I worked with a fellow that actually had scripting language for the animating the lights. Actually you had to write your animations in Notepad, and that got old pretty quick, so I learned that. But about 10 years ago, I'm an IT person. I work for Akron U, branch campus over there, and I've been doing computer stuff for about 34 years now because I book it. But about 10 years ago, I was going for a degree because you get free classes working there. And one of the classes was grant writing, and I asked the dean, could I write a grant for a 3D printer? And he said, go for it. So that started the birth of a makerspace at our college that I get to run, which is pretty cool. I don't get any financial recognition for all that work, but that's another story. But I got into 3D printing, laser cutting, vinyl cutting, poster making, CNC stuff. It's a blast, total blast. Back when I went to high school, and many of you went to high school, we had wood shop, metal shop, home ec, remember all those kind of classes? Yeah. For building stuff. All still awesome things to have. But nowadays, you walk into a high school, they've got 3D printers, they've got laser cutters, they have these digital fabrication machines that I wish I would have had when I was in high school. And even the vocational schools are incredible. So I've been working with 3D printing stuff for about 10 years now, and I know a fair amount, but I'll bet there's a lot of people in this room that can teach me a few things or two. So I'm hoping that as I talk about stuff here, feel free to chime in, and there may be a gift for you involved when you ask questions. So think about it. I brought a 3D printer that we'll talk about off and on. Does anyone recognize what I'm making on it?
Pixel pusher.
Okay, saves your fingers, saves you from getting blisters and everything. So we'll talk about how that works and everything. So again, this is going to be beginner all the way, to all sorts of levels here. Okay, so let's move on. All right. I have a lot of links in my slide for different websites and things like that. So if you want to be able to call those links up, and so you don't have to take any notes if you want to, snap that with your phone. It'll take you to a page that shows a copy of this PowerPoint if you want. It'll have all the stuff I'm talking about in that PowerPoint. If you don't have access to taking that picture or using the QR code, that website at the bottom there, with those menus there, if you go to itwinkle.org and hit the support menu at the top, that'll take you to a list of all the presentations that Light Up Ohio has done for the past 6 years, maybe. I've got all those mostly recorded as video and PowerPoints, and this one will be in there too. So if you want to reference any of the videos that Clyde or Kevin talked about today, I've got those. And, it's all there. So that'll save you some time there. So everyone got it? Okay, great. Okay, so basically what we're going to talk about today is a little bit about the history of 3D printers, okay? How they work, just the basics. How they apply to the Christmas lights hobby, how we're using them with what we do. Should you design your own shapes? Okay, these are called STL files, the different objects you do. Or should you buy shapes? Should you print your own shapes? Should you get a 3D printer? Is it worth getting one at home and learning it and getting frustrated with it? Or should you have a company print things for you, for these things? What's the better route to take? And where do you find them? We're also going to talk a little bit about the makerspace community. I don't know how many of you are in the Columbus area, probably a third or half of you, but there are makerspaces around here that you can get access to these machines. And so if you don't want to try a 3D printer at home, you're not ready for that plunge yet, but you need to have some things made, you can actually go into a makerspace and have them made there, and just learn from their printers. So we'll talk about that too. And then some printing tips that if you do have a printer, how to make your experience more successful and less frustrating. right? So feel free to stop me. We got plenty of time to talk about stuff. Be happy to. So 3D printing has been around a long time, longer than you think. The guy on the left there, I'll give you his name in a minute because I can't remember what's on the next slide. He's the guy that invented 3D printing, and I think it was Chuck Hall back in 1986. So he made what's called a resin 3D printer. Remember resin? You've heard of those, right? Because that's a real popular 3D printer with some people. That was the first kind of 3D printer that was made. So it's actually, this makes things with plastic, but a resin 3D printer makes things with laser beams and liquid resin. So the more sophisticated printer was actually invented before these kind of things, which I thought was kind of curious. And the middle picture is the founders of MakerBot Industries. That was one of the first consumer-level 3D printers that companies that started producing printers. And they're showing one printer that they invented right here, printing parts to make a child printer. Because that's what they do. So again, that's so the first printer was invented. The idea was invented in 1980. The first patent was awarded in 1986. But the patent expired in 2009. So the reason why you haven't seen 3D printers for sale on Amazon and all these different places because there was a patent behind it. So that company, I can't remember the name of the company, but 3D Systems, they're the ones who own the patent, and they just use that 3D printer for the manufacturing industry. So when that patent expired in 2009, that's when you saw this explosion of 3D printing because everyone was allowed to make them and sell them. So I thought that was kind of curious. This technology has been around for a long time. So just a few interesting slides here. This thing makes things out of plastic, but 3D printers are about all sorts of materials, and not just plastic, not just resin. So there's actually 3D printers that make things with concrete, like houses. And the 3D printers are huge. They're either the size of maybe 2 of these tables put together, and they're on wheels, and they're robotic. So you might have a 3D printer roll to a place where a room needs to be drawn. They'll actually build layers of concrete to make a room and roll to another part of the house and draw the other room. There's other 3D printers that literally, the company comes to build a house, and they erect a gantry structure like this, the size of the house going across, and it draws it just like this, but the house is down here. So they make things that way. So we're not going to be doing that with our hobby, but I just thought that was kind of fun. This is the thing. You can make houses cheaper and faster with fewer people, for the structure part with 3D printing. So biomedical, again, not just out of plastic. The nozzles can actually have organic material in them. And the trick with this is not just for skin, because that was a repaired ear based off of 3D printing, but they're trying to make organs with 3D printing, like kidneys or livers or things like that. And the idea is if you have an accident and you have to wait for months, years for an organ donor, right, that you can have one 3D printed, and that you might survive your wait. And that's happening. There was actually a research team, I think it was based in Iran, or Israel, one of the 2 places, where the researchers were actually 3D printed a rabbit's heart. And the trick to that is when you have organic material coming out of the nozzle, it needs support nutrients, it needs oxygen, it needs other nutrients to keep that organic material alive. So what they were able to do was to 3D print the muscle material, the vein system, the arteries, whatever, that surrounds the heart to keep it living. And so they actually printed the heart. It was actually a living entity when it was done. It stayed living. Now, it wasn't a beating heart, and they didn't put it into a rabbit to see if it could be transplanted. But they did demonstrate that they could actually make organic material that survives the printing process. So, expect in about 10 years or so that your next liver that you need, might be a 3D printed one. It's a pretty big deal. So one more thing is, would you eat 3D printed meat? Okay, this is a delicacy. It's called the Japanese Wagyu beef. Quite expensive, but they demonstrated that they can do the same technique with where it prints the muscle, the sinew material, and all that kind of stuff into this. And the idea with this kind of idea is, if you have a global warming, right, and you have climate emissions, damaging, with the warming of the sun and all this kind of stuff, there are many things that contribute to the stuff getting up to the atmosphere and causing global warming. but would you believe cows are a big contributor to global warming? Do you know what part of the cow causes global warming?
Methane.
Right, methane. They fart. And believe it or not, that's a big deal. When you have a lot of cattle in the world, raising for beef and all that kind of stuff, they consume a lot of food. They take a lot of space because they have to graze, and they excrete a lot. So if you can get your food in other ways that isn't as hard on the environment, you're doing things like this. So anyway, I thought these slides are kind of fun. Okay, so how do these things work? Okay, I just finished printing that. Let's start this real quick. Okay. Oops. Okay. So a 3D printer, this material right here is called filament, right? And it's basically a kind of plastic. There's multiple kinds that we'll talk about, but it looks like weed eater line, but it's not really. Weed eater line has fiberglass in it. This is like pure plastic. So the way a 3D printer works is the filament goes into this head. The head gets to about 215 to 230 degrees Celsius, which is pretty hot. Turns into a liquid inside the head and extrudes it out the bottom. So if you're thinking of like an ice cream machine or a hot glue gun where you're just building layers of plastic, that's all they do. So to make all these crazy shapes on 3D printers, just layers upon layers of very thin plastic. So we'll pass this around because it's just finished. And now this type of technique is called additive manufacturing. Okay, so you're adding material to build stuff. Traditionally, things are made with subtractive manufacturing, which is bowling balls, or carving a statue out of a block of marble. You're chipping away material. So this is more like you're using less material because you're not having to chip away stuff. Make sense? Well, for sure. So, but that's the basic idea. We'll talk about some more in just a minute. Okay. Again, the nozzle gets really hot. It builds up layers of plastic. The layers of plastic are pretty fine. So typically they're 0.2 millimeters, which is about the thickness of a sheet of paper. So if you're thinking of making, that's a really big deal, because when you're trying to make stuff on a 3D printer, you might buy the biggest 3D printer you can buy, and think you're going to be making these huge jumbo balls, or you're going to make, Coro props with your 3D printer, but they take a long time to make things. So something like that pixel pusher took about an hour to print that. So you're not talking about lots of big things. What these are good for are complicated small things, or lots of small things, like pixel clips, or gutter clips, or things for your PVC pipes, or things like that. People do make big things with these. I mean, there's lots of things. One guy made a kayak. He actually 3D printed all the different parts of the kayak and glued them all together and made a floating kayak before he died of drowning. But there's trade-offs to doing this. You can actually print your stuff with thicker layers, so they take fewer layers to make, right? So you save time, but you're still talking about a pretty slow process to make stuff. Okay. And that's going through a warm-up phase, and it's an automatic bed leveling. We're going to talk about that too. So there's some pretty big things to understand. Now, the kinds of plastics that you choose for a 3D printer are pretty important. The most common kind that people like to use is called PLA. It's a polylactic acid. It's a cornstarch derivative plastic that's somewhat biodegradable, but not really. Okay, people think it's good for the environment, but it's really not, because it takes a really long time to decompose. But the nice thing about PLA is its low temperature melting point. So that means that it doesn't take as hot of a nozzle to get onto the plate, and it doesn't have problems with warping. Okay, and what I mean by warping is with some of the other plastics, as soon as it goes down onto the plate, it starts to cool. So there's tricks. Some printers have heated beds to keep the plastic warm so it doesn't cool too quickly. But if it cools too quickly, the plastic will shrink. So if you're trying to print something like a cube, the corners of the cube might start curling up from the bed, and you won't have a very square cube anymore. So PLA doesn't cool that quickly, so things you print tend to keep the exact same shape of what you intended. So it's the most common kind of plastic because it's easy to work with. The only thing that's bad about PLA is it's not very outdoor friendly if it gets really, really hot. So if you put like that pixel pusher inside your car on a very hot day, it'll actually get a little bit bendable or a little bit malleable. So, but for the most part, I feel that unless you guys have some better ideas, if you put anything with PLA outside for your Christmas props, the sun hitting it is not going to be enough to cause it to warp or deform because it's just not a hot enough environment overall. So I would recommend in general that you use PLA. But
unless you're adding it to your attic, if you're storing stuff in
oh
the
yes,
attic,
right, like a hot.
It will deform after 90 uses.
Right. In a very hot environment, it'll start to get the pitch. Right. But if you're looking to start with 3D printing for the first time and you don't want to get frustrated, start with PLA and then start working with the more advanced kind of filaments. The other kinds, ABS, is we used to start with ABS. That's the same kind of plastic as Lego. So I can't pronounce what it stands for. But it's very good for outdoor stuff, but it's not very UV safe. So if you make something with ABS, I mean, for this hobby, it's going to be fine. You don't have to worry about longevity for 50 years, you know. But it isn't UV stable, so the sun can't go down over time. What most people are going with for outdoor plastics is called the PETG. And that's the same kind of plastic that's in your Pepsi 2-liter bottle, you know, that kind of plastic. So the problem with ABS is if you print it, it's got a high chance of warping off the plate, right? You get some shrinkage going on. There's ways to fight that, you know, but it's still a struggle, it's still a pain. So I generally recommend not using ABS for anything. PETG is a little bit better than ABS for printing, but it's still going to give you some trouble. So, you know, but if you need outdoor stuff or in a place that's going to be hot, start working with PETG. Okay. And again, that shrinkage problem happens typically when the plastic cools faster than it can set in place, right? So if you have like a cold draft coming into your printer, that would cause warping to happen. Some people get an enclosure, like a box for the 3D printer to keep all the warm air inside the box without any drafts. If you really want to do it right, you get something with a heated box and it stays at a certain temperature. But again, I would just start with PLA and then just work your way forward.
I'll add on that, if you have a bamboo, the one has this, they have the enclosure in there. And so you can, the lid, it's an enclosed printer, and you can take the lid off or PLA and keep the temperature down. With PETG, you can close the whole thing, put the lid on top, and it's got fans inside that keeps the temperature exactly, because it knows what material it's printing, so it keeps the temperature inside the chamber exactly where it needs to be, so you don't run into nearly as many issues with PETG printing in an enclosed printer than you do with, like you were saying, with the drafts and stuff on one like this. Yeah, it makes a big difference with the enclosure.
And another thing about the enclosure that helps is some plastics put out more VOC particles than others. So those are volatile organic compounds, right? So PLA is fairly safe-ish, you know, but ABS is bad. You know, if you're inhaling ABS vapors or fumes, it's not good for you. So having an enclosure keeps those fumes in a minimum, or
You have to vent ABS outside.
yeah, or have a filter on your enclosure that's like some kind of filter. You know, that helps.
I would vent it outside.
Yeah. So again, PET is probably your best balance of outdoor stuff. It's fairly safe.
PLA and TET.
Yeah.
There's another one, ASA, that is a newer filament that is outdoor rated. It's got the benefits of the ABS, except it doesn't stink as much. And I tried printing some of it in my basement. Mine had filters that blow through, and it was to the point where I had to kill it after 5 minutes.
Oh, okay.
It stunk so bad. So PETG, they say ASA is the best one for outside, but unless you're saying what he said, you vent those, I mean, it's just, the smell is just unbearable. And it's bad for it.
Actively vent.
Yeah.
And some printers need, some filaments take a high temperature to work them. Like PLA takes a fairly low temperature nozzle. When you get into things like ASA and some other ones, you have to make sure your printer can support melting it, right? Because some printers can't go that high with temperature. So just double check. If you're going to buy a printer and you think I'm going to be printing ASA, make sure your printer supports ASA temperatures. Does that make sense? So, okay. I'm talking way too much because I'm going to cover everything on I intend to talk too much. You can print things that are transparent or semi-transparent 3D printing. It's a trick. You know, I just actually helped the fellows do some bells for a Christmas ornament display for his wreath. Yesterday, we bought some transparent PLA. And it's not like see-through glass. I mean, there are tricks you can do to get pretty see-through, but it's not. It's kind of a science. You sort of have to learn how to do it. You can either run the filament hotter, or you can use thicker layers, or it's a science. Okay, so but you can do it if you try some ideas. So PLA or PETG filament is the kind you want to get for transparent trim. If you want to do like a light bulb that glows, right? You can print the base in green and the top in the semi-translucent plastic. Your printer might have a mode. Your software, which we'll talk about, is called base mode. Have you guys heard of base mode? See, typically when a 3D printer is printing, suppose I'm printing this thing, it'll draw the outline of the handle because it's going to be sitting like this. It draws the outline of the handle, the print head moves up, it draws another outline of the handle and keeps moving up like this. Every time it moves up, it's got to reseat the head on the layer it's on. Plus, if the skin of this is like this thin, it's got to print that wall of plastic around your handle. So all that reduces transparency. What base mode does is it tells the printer to make spiral patterns going up. So it doesn't jolt and stop per layer, and the layers are extremely thin. So if you want to print something that's very clear, right, as much as you can, in your printing software you have a feature called spiral mode or base mode. And you turn that on and you might get a surprisingly beautiful bulb that's easy to see through. It might be a little bit more fragile, but you'll get the effect that you want.
Are you going to talk about litho things then?
Litho things are, you can tell me real quick.
Well, it's an amazing thing that you can get with 3D printing where essentially it's everything he just said, but it's this very thin thing, and what you'll see is, oh, that's just a thin sheet of plastic. But if you back illuminate it, you can add the detail of a photograph. It's stunning.
I recommend lithopaintmaker.com, and I did a cube for some friends of mine, I know 4x4, I think, Tom, I sent you the video of it. And it's, they basically, you put your pictures in, tweak them around a little bit, and it's pretty easy to get that. My 6x6x6 cube took 36 hours to print, but I printed it in PLA.
And the way that works is it takes the plastic, the thickness of the plastic, so it makes the plastic thicker in some areas and thinner in other. So if your photo has different shades of gray, the thicker areas might be thicker plastic for the darker grays and thinner plastic for the lighter grays. That's how it can handle the litho.
Think of a black and white photo.
Right.
But you pick the background color because you're printing in a solid PLA color. But the point is you can print amazing Christmas items with this technique.
So I'm going to make your day. There's a new program that came out, it's still in beta, but you can buy it for $18. It's called HueForge, HueForge, and it's awesome. What it does is it takes the filament, you load a photograph into this program, and what it does is it stretches the film out really thin and makes really fine layers of blue, red, white, and black, whatever you have loaded in your printer. And then it actually depends upon the layers seeing through to the other colors because they're so thin. So you might print a picture that's like 4 colors of filament. You can tell this printer to pause. Any printer can do this trick. You pause it, and then you can switch to a different color and tell it to resume printing, like a stratification layer on a rock. But because the layers are so thin, you might load white in there, but get 5 shades of gray when it's all done printing because everything's thin. So you can make colored litho paints, which is awesome. So that's going to ruin your day tomorrow.
What's the name of it? HueForge.
HueForge, H-U-E Forge. We just bought it. You get it for $18. You get beta with 2 free updates for 2 years worth of updates. But then they give you $18 worth of a filament coupon with free shipping. So basically, you're getting filament for $5, and you get the program for free. So it's awesome. So yeah, we've been making photos like nuts. Okay, you can also print with typical 3D printers. You can also print with rubber filament. So if you need to do something that's flexible with what you're making, a TPU is called the kind of filament it is. NinjaFlex is a brand of TPU filament. So make sure, if you do get a printer, make sure it supports TPU or flexible filament because not all printers can handle it. It's harder to push it through the nozzle system, but a lot of printers can handle it nowadays, but just double check and make sure your printer can do it. Okay, so using the printing software, most printers come with software. It's called slicing software, and the reason why I call it slicing is because it's taking your object, right? And this every layer that it builds is called a slice, right? So it's taking your object and converting it to a whole bunch of different slices. And the software tells the printhead where to move within each layer. That's all the printing software does.
It's the same thing that an MRI does if you've ever had an MRI or a CAT scan. It takes layer pictures of you.
Okay, yeah, same idea. So in the 3D printing software world, when you need to print something, like I needed to print this, I downloaded this shape from Thingiverse, and we'll talk about that in a little bit more. It's a repository of objects. So you download this shape from the internet. This shape, the file format is called STL, so stereolithography. That goes all the way back to 1986 when Chuck, what's his name, invented that format. Okay, so you download an STL file, and then you load that STL file into your 3D printing software. You can do things like resize it. You can choose with 3D printing because I'm building the layers. I can control what goes inside of this and how strong I want it. It can be solid plastic. It can be a mesh, like a honeycomb mesh. You know, it can be all that kind of stuff. So in the slicing software, you can set parameters, right, for how strong you want it to be. We'll talk a little bit about that more. So when I've loaded the STL into the slicing software and I make all the settings I want, then I have to output what the slicer makes to the printer. That's another file format. That's called G-code. That simply says the print head is moving from point to point and extruding at certain points. So basically, you download an STL, load it to the slicer, you generate a G-code file, and then you send it to the printer, right? So this printer here has a memory card, so I just load my G-codes on there. So if you have a certain clip you like, you can actually just keep that file on the memory card and pre-print these instantly without having to touch the computer again. So it's kind of a nice way to reproduce stuff multiple times. Okay. Now, as far as the software that comes, your printer might come with a certain kind of slicing software, like its own proprietary kind, like a Creality. 3D printers come with Creality Slicer, right?
Everybody uses Cura.
Right. So there's a couple universal ones that work with any printer. So if you don't like the one that comes with your printer, there's a good chance that Cura, which is a popular one, or Prusa Slicer, might work with it. So you might get a 3D printer that's a bargain basement, but it comes with crappy software. You can probably load Cura as a replacement slicer, and it works just perfectly fine. Okay. All right. So about this 3D printing software, I just want to explain a few of the important things about 3D printing. Okay, we talked about the infill. You can't really see it in this picture because it's black on black. But this one was printed with 10% infill, so the honeycomb mesh is really open and wide. So that prints very quickly, right? Because you're not using much plastic, but it may not be very strong because it could break. So you can choose to increase the density, like 30% infill or 50%, or if you want a perfectly heavy part, you can go at 100%. Dave, can you pass around some of your stuff that's the heavy stuff? So some people like to print with 100% infill, which is like pure plastic. They have a super strong part. And some of these are heavy.
And you'll be able to see the interior on this piece and see that this has got like 90% infill.
Right. Okay. You also have a theory, an idea called supports. Now, because everything you print on a 3D printer is layers upon layers of plastic, printing something like this pixel pusher would be printed like this, like an inverted T. But if I would have chosen to print the pixel pusher like this, like a normal T, what would happen is the printer could print the column part of this well, because it's plastic on top of plastic. But when it got to the legs of this, the plastic would collapse. There'd be nothing for it to hold it up, right? So within your printing software, you have an option called supports. And those are temporary columns of plastic to print that holds up the T. And when it's done printing, you break those off. Okay, so that's another option within your printing program. So whenever you load something in your printing software, you have to be very mindful of the orientation that you're going to print it, because that affects how well it's going to print. Now, another thing that might not be so obvious is these layers that print. Those are heavy, those are hot layers of plastic touching other hot layers of plastic, and they fuse, right? Well, that fusion is not perfect. So that becomes a weak part of your print object. So all my layers on this are this way, right? Because I built it like this. That means that this way, if I tried to break it with my hands, that's the most likely way I can break it, right? But if I try to break it, this way against the layers, it's hard. It's not going to break at all. So whenever you print something for your props or whatever, think of where the stress point is going to be. Is it with the layers or against the layers? And if it's, so make sure you orient it properly so you get the best strength. Okay, so those layers don't beat you there. So that's supports. That's So supports are like this dog right here. It's holding up the head and the belly. Does that make sense? And those break off. Okay? Just real quick, we talked about layer height. Okay, this is how fine each layer is as it's printing. Thicker layers means faster. Okay? You might lose a little bit of detail, but it'll speed things up a little bit. I have read somewhere that if you use thicker layers, the fusion may not be quite as nice, so you might have a slightly more breakable part. Okay? So if you go with finer layers, it's probably going to be a stronger part overall. But if you need the speed, like you're doing like a bulb that's big, you're not going to want to wait 24 hours for that thing to print, right? So you might use thicker layers. Okay? Does anyone else have anything they do with their 3D printing software that that works well for them? For some of the options you gave?
So with my bamboos, I have what's called an automatic material system, so I can run up to 12 different filaments, and it'll automatically change them, tell you so I can print up to a 12-color print. And what's really nice about the support that you showed in that photo, it can print multiple, so you can do support PLA and PETG over the wall, and stick down stick. So with the bamboos, you can put your supports in PETG and print your object in PLA or vice versa, and then that way the supports come off really nice, and they don't leave those break lines that you get when you use a support like PLA on PLA and you print the same color. So it's nice for that. Which is why I would suggest if you can spring it and you're going to go buy a new printer, I'm a big fanboy, so, and because there's so many options and they're easy to set up, they're very beginner friendly. They help with stuff like that because it's complicated with support.
Yeah, we'll talk about the brands here in a little bit.
Oh, okay.
Hold on a second. The other thing about supports is because you're putting pillars of plastic that hold up other parts, sometimes that plastic will fuse so hard to your part that you can't break it off. So it depends on the quality of your printer. But what you were saying is you can print, if you have a printer that can handle multiple kinds of plastic at the same time, you can print the main part of one kind of plastic, like low temperature PLA, and then the support material and another kind of PETG, they don't stick well together. But it's just enough to hold it up for supports. So, yeah, go ahead.
I was going to mention something similar. I use Simplify 3D, which is a different slicer.
Yep.
And one of the things that I wanted to do was I wanted to create tags for some of my props, because some of my props are very specific with how they have to be plugged in. So I had panel number 1, panel 2, panel 3, panel 4. And I used 2 colors, and I used the Prusa slicer to go in and edit the Simplify 3D slice that I had given it to change, to stop the printer at a certain height so that it would change the color. I could back out the one filament, so it would automatically do that. So that was something interesting that I learned, is that I could take something I had already sliced with one slicer, go to the Prusa slicer, insert a stop point so that I could then change my filament to a different color, even if my printer didn't have the ability to have multiple colors attached to it. And it worked really well. I had a black background with a nice red lettering on it, so whenever I had panel number 1, it said panel 1, panel 2, and you could see the red was on the top and the black was the background. So it was a nice little fun thing to mess around with.
And that's how the hue force works. You actually tell, I want a picture with 4 basic colors, and they say, at this layer pause, so I can change the filament. At this layer automatically pause, change another filament. So you can do that trick with that filament too. Okay, so how do we use this in our hobbies, right? How can we use 3D printing to help us with making our hobby better, okay? There are lots and lots of designs on the internet and from various companies to help you with all sorts of things with this. A lot of custom clips. It's amazing. There's hundreds of cool things that would instantly make your life easier. So I'll look at a few of them, but a lot of them are house clips for gutters and shingle clips for pixels, your house eaves, things for your siding. Like for years, I had the corners of my houses, the vinyl corner pieces, right? I didn't know any better, but I had my Pixaball type pixels actually put on a wooden piece of stripping, and I would actually foam tape it to the side of the front of the gutter. It was really hokey. And but eventually the tape would fail, and sometimes that piece of wood would fall off. So it was really, really silly. And here it is. But then I found something like this. That's a gutter corner piece for holding something up, right? So you actually snap it around the sides of your gutter corner, and it locks something in place. In this case, it looks like it's a piece of PVC pipe. that would go up in the corner of your house. But I actually took that shape and I modified it to wrap around my piece of wood that was holding my pixel balls up. So basically, I put my strip of wood lights up there, I snap a clip on the top and the bottom, and I'm done. So, see, what's really cool about this stuff is you can find things that will suit your needs perfectly that you can't get anywhere else, but then eventually you're going to want to customize things and make it work just for you. That's what's really cool about this thing. It really enables people to make things that they really couldn't make before. You know, if you're willing to learn a little bit of tweaking with either CAD design. You know, when I started in college, I never got into CAD. We taught it, you know, but I didn't think I was smart enough to handle all the math and all the computer stuff. I just never got into it. But when I started messing with a 3D printer, it was like I wanted to make some of my own stuff, and I found out it's not that hard at all. You know, CAD, in my opinion, is basically taking shapes and putting shapes together to make other shapes, like cubes or spheres or, you know, prisms or whatever. That's really, to me, all that CAD is. I can make really fancy stuff with just putting basic shapes together. So it's not intimidating. We'll talk about that in a bit. Pixel clips, mounts for your mesmerizer displays. These are probably PVC pipes right here with 3D printed braces that connect everything together. Piece sticks, adapters. You know, it's amazing. And I'm going to show you some of the places where you can find this stuff. What else can you make? Pixel pushers, like I just showed you. You can make entire props out of 3D printing, which sort of blurs the line between 3D printing is really slow. Is it really worth it if you're trying to make something big, right? So you have to have that kind of balance, and I'll talk about in a little bit. You can 3D print adapters to take traditional Christmas lights and adapt them to your display, or you can take a traditional prop and modify it with 3D printing to work with pixels. You know, that's what this stuff's all about. This is an arch brace, you know, for building arches with PEX tubing. Controller mounts to mount controllers within your box or right on your power supply. It's endless. It really is endless.
Tom, do you want me to show them the examples?
Yeah.
So one of the examples, he's got, go prior slide, Tom. Stars and spinners. So this is a 3D printed mounting element. The idea is this will hold standard, you know, 1/2 inch galvanized EMT, cheap, readily available. You slide this down, it's got a set screw, so you can set it wherever you want on the pole, up and down. Then see all these holes around the side. I'm sorry. You put basic gardening fiberglass rods in there. There's set screw locations to lock them in, and then you can do mount whatever lights you want on the spokes. So make a star. This is the exact same idea, only again mounted on a pole, got a set screw, put fiberglass rods into it. But this is for making horizontal things. So you could make fire stick out of this, for example, or a tapered tree. But again, these are made out of these are PLA, and one of these things cost probably about, well, certainly less than $1 to print. So these are just, I'll pass these around. These are just two examples of, it really, as Tom's trying to tell you, the sky is the limit in terms of the interesting things you can do.
Did you print those yourself?
I got those from a friend.
Okay, I wonder how long it took to make those. So those are probably solid plastic. Those things, you can throw that at somebody, it'll kill them. I mean, they're way beyond the strength you need. So what's the benefit of 3D printing over traditional methods? You know, like if you do woodworking or metalworking or welding, right? In my opinion, 3D printing is best for small things like pixel clips or house clips for things. It's good for repetitive things if you got to make a lot of stuff, you know, a lot of little things you can actually tell 3D printer to print like 20 things at a time, you know, on the print bed. Or very complicated designs or custom designs. Like, you know, I think you guys were with me last year. I was retrofitting RBLs because Dave got me started on the RBL thing when he talked about it about 4 years ago. And if you go online, you can find adapters to retrofit your RBLs for pixels, right? Yeah, just like that, okay? And some of the designs I found were you have the bulb and then you have the socket it screws into. So the design you download was a replacement socket piece, the inner socket piece that the bulb screws onto. But it's like a cup that you printed with the new threads on it. But I needed to make like 65 of them, and I didn't want to print 65 cups, so it would take forever. So I designed a little insert here. See, I have a little light green thing here. I actually shaved out the battery compartments, attached this 3D printed tiny little piece of plastic, and then I laser cut a disc that it attaches to, and then I've got my adapter. So basically I can print all of these like super fast. I didn't have to waste like a spool of film. And you know, just a little, and I learned how to do it. It's just kind of cool. I made my own solution. So I wasn't stuck with someone else's idea, which is good. It depends on what you're trying to do. You know, that's what's really fun about these. You get an idea, it's like, I can make that. You know, I can make my own stuff. And it's awesome. But if you need to make big things, you know, like wireframe props or you know, 4 foot tall, you know, monster things out of wood, obviously 3D printing is not going to suit your bill. It's going to take too long to make things, you know, and it may not be as strong. So 3D printers aren't a solution for everything because they're just slow. They're just basically slow. Okay, so it's good to know a little bit about it.
Don, did you load your designs up with Thingiverse?
What's that?
Did you load
Everything because I'm Thingiverse. So we're going to talk about that. Yeah.
Man.
We're going to talk about that. Okay, so where do you find these kind of shapes, you know, for Christmas hobbies? For all the clips I showed you, pictures like that? These are all the different places. The first 4 links are... No. Oh, whoa, that's a totally wrong slide. Wait a minute. That's on a different slide. Okay, I'm going to get to that slide. I lost it. It's somewhere else in the deck here. We'll get to that. This is where you can get help with 3D printing. So we have... It was a late night last night.
But you're not far from it. You can find it.
Oh yeah, I'll show it. I think it'll come up. If you go to the there's a Facebook page called the Official X-Lights Sharing Group. That's where you can find shapes. Actually, that's partially correct slide. I think I did something weird. The Official X-Lights Support Group has a files section where you'll find STL files for a lot of things. And these other 2 groups down here are Facebook pages if you need help with 3D printing. Okay, you can post your questions on there and they can help you with things related to Christmas hobby. Now, what Dave was mentioning was Thingiverse. Thingiverse is a place where people that have cool ideas upload their ideas for everyone else to share. So there's millions and millions of cool things on there, not just Christmas hobby. It's like everything goes. You know, if you need a spiked collar for your cat, or you know something to explode a pumpkin, you can find it on Thingiverse. People invent stuff and they share it with everybody on there. So if you just go to Thingiverse and you type in like pixel, you know, or Christmas pixels or something, you'll find a lot of cool things on there. Printables.com is also a place where you can find things to download. And most of those are free. Oh, here, okay, these are all the other ones. So these are companies that they have a lot of great Christmas hobby-related designs, like brackets and things, but they'll sell you the design. So you might have to pay $2 to download a gutter object or something, and then you 3D print it yourself. And some of these companies actually will do the 3D printing for you. So if you find something they sell, they'll often print it for a price and then mail it to you, so you don't have to mess with the 3D printing part. So all these links are live links if you download that slide deck from that link I gave you. Okay, but you probably recognize some of these. Flash the neighbors I have not heard of before. So that was new to me. Okay. All right. If you want to get into your own, if you get like to a point where you download things and you print them, and that's great, but you get to a point where it's like I want to customize something that I've downloaded, or I want to make my own stuff. The program you probably want to mess with is called Tinkercad. And it's a browser-based CAD program, so you don't have to install anything on your computer. It runs in your web browser. So you can do this with a tablet, right? Or you can do it with a laptop with a browser on it. You know, probably not your phone, but definitely a tablet. And it's free to use. It's made by Autodesk that makes AutoCAD, and you can just create an account for free and start messing with it. It's pretty decent software to start with, okay? But eventually you're going to outgrow it, and you're going to want something a little bit more sophisticated, and that's called Fusion 360. They're now just calling it just Fusion. That's also made by Autodesk. So if you download Fusion and you tell them that you're wanting to use for personal use or a hobbyist use, they let you use it for free for a year at a time, and you have to renew it every year. okay? But it's very, very powerful. The free license, they take away some of the features that you really wish you could have had, which is kind of a rip-off, but they do give you a nice program overall. And the main difference between Tinkercad and Fusion 360, I just forgot the name of it, parametric modeling. Okay, does anyone know what that is? I just learned this not too long ago. Parametric modeling is, suppose I made this in Tinkercad, right? I learned how to use Tinkercad to draw this. If I printed this and found out that, I made this slot a little bit too narrow, right? It won't fit on the pixel too well because I made it too narrow. In Tinkercad, I could probably tweak it a little bit to make it fit. I can actually manually massage the shape and stretch it a little bit and get it to print and work right. But that's about the best I can do. With parametric modeling is I could actually design the shape in Fusion, right? And I made that slot originally 5 millimeters wide. I could go with Fusion and say I need that to be 6 millimeters wide, and everything around the shape will automatically calculate to fit that change. So you don't have to redesign. You can do a lot more changes, and it changes like if you build a car on there and the wheel is too small, you say I want the wheel a little bigger, and the whole car gets bigger. I mean, to fit the shape properly. It's not a simple rescaling. It's actually mathematically figuring things out. So it saves you a lot of time. So that's a nice thing. If you're modifying an existing design, that's where Fusion comes in really handy. And YouTube is a great way to learn these two CAD programs. Lots of tutorials out there. Does anybody use Fusion? You do? Okay, you do back there. I used one before that called 123D. That was the precursor to Fusion, and it's not parametric, and I'm paying for it. So, okay. Printer buy. Should you mess around with getting your own 3D printer or not? Okay. If you buy a 3D printer, you got to buy the printer. You got to pay for the filament. Right? Filament's pretty cheap. You can get these rolls between 10 and 20 bucks. And they print a lot of stuff on a roll. It lasts a long time. Printers can run anywhere from $200 to $300 to $2,000 to $3,000, depending on what you're trying to do. Okay, so they're cheap, but the nicer ones are going to cost you a little bit of money. What's that? We'll talk a little bit about the kinds of it in a bit. But you also got to worry about if you get a 3D printer, are you willing to fight with it? These aren't toaster ovens where you just take it home and put it on the counter and they just work. Some of them are. The nicer ones just work. There's nothing to them, and they mostly work all the time. But if you get some of the more budget printers, you might have to tinker with it. And this kind of crowd likes to tinker because that's what we do. We're in the Christmas lights hobby. But you may not have time for that. So you might want to, instead of buying a 3D printer, you may want to have somebody print it for you. So you may download a cool shape from EFL Designs or whatever, and then you can take that shape and send it to one of these 3 websites where they can print for you. So those are printing services. And they're not limited to just plastic. If you need a certain part that's metal or whatever, they can print exotic materials out of this kind of stuff. So that's something to consider too. So I'm going to kind of really quickly here, so I don't want to blow everyone away with too much information. Am I doing okay, or any questions about stuff? Are we good? Good? Yeah.
Probably getting ahead, but you mentioned cost. Are you going to talk about cost?
A little bit, yeah.
Okay.
Yeah. Like that printer right there is a Prusa. That's probably $1,000 printer now. They have a Mark IV. It's now $1,100. You can buy that one 2 different ways. You can buy it assembled for $1,100, but you can buy it as a kit where you put it together, and they give you excellent instructions to put it together. It's probably like $800 or maybe $700.
It's a 7-hour project.
Yes, it's an all-day project.
It's an all-day project.
Yeah. So I'm going to show you a website that helps you pick one out really easily. That's probably one that's best for your how easy of use you want and the cost. Okay, those make that a lot easier. Okay, where do you find these things? They're available everywhere. I mean, Amazon, what doesn't Amazon have, right? Okay. Micro Center here in Columbus has them. I think they have a dedicated area just for 3D printers. The best, in my opinion, the best printers that are ready to run, where you just take them home and they just work, and they work consistently. You don't have to find them too much, and they have excellent support. Because if you buy the budget ones, you may not get the help you need unless you go to Facebook and just ask the crowd how to get help. I like Prusa quite a bit. That's this one. They're a Czechoslovakian-based company, which kind of thought, how you're going to get support from them. But but they're excellent. They have the best support. They have one of the highest rated products. They just work and they work well, but they're kind of pricey. You know, we're talking $1,100 for one of the printers. But the other one that a lot of people like is called Bamboo, and it just got popular about a year ago, something like that. Very fast printers, that's what they're known for. So if you're worried about the speed of a 3D printer, they're probably a third to twice as quick as a typical 3D printer.
Are they running Clipper? Is that how they got faster?
They're using, yes, they're using a feature. There's a new buzzword with 3D printing called input shaping. And what that does is any printer can do input shaping if you teach it. You have to sort of calibrate your printer. And the reason why it's faster is any printer can run quick, but keeping it accurate is tough. You know, when the motors are going so quick and the gantry is moving so fast, there's slop. And if you can account for that slop, you can mathematically say when you're doing a corner, slow down a little bit. Or if you're doing these certain movements, you know, adjust the motor so it's going to maintain the accuracy. That's called input shaping. So that's what the Bamboo does. It can run very quick, but it sort of knows its motor system and its gantry system and its rail system really well. They can run quick and still stay accurate. Okay, so yeah, a lot of printers can do Clipper, you know, but if it doesn't have Clipper when you buy it, you have to teach it. You have to go through a pretty lengthy calibration process. It's better to buy it already done. So, okay, so here's that website for you, Joe. all3dp.com. I think I mentioned this at another talk I did for this group last time I talked about this kind of stuff. This is the best website for 3D printing stuff, bar none. They have a mailing list that I'm on. They send you articles like twice a week about all sorts of very helpful articles, but they also have buyer's guides. So twice a year they update the buyer's guide to what's currently popular, and so they'll have like a high-end recommendation, a budget level recommendation, all they put them into categories. And Bamboo's been at the top for a while. Ender's at the top, sort of at the top for the budget category. And I want to talk about that a little difference. And we'll probably start fighting with pitchforks once I talk about this. The Prusa's and the Bamboos, you buy them, you unbox them, they work, right? The Ender is excellent price. It's got a huge user base. A lot of people buy these things. But they take a lot of tweaking to get them ready. They might work fine out of the box, but they may take a lot of babying to get them working. But once you get them dialed in nicely and tuned in nicely, they make excellent prints. So if you're the kind of person that you like fiddling with it and perfecting it and getting it nice, Ender might be a good choice. But if you don't have, if you just want this thing to work and you've got to move on to other things in your life and you're willing to spend a little bit of extra money, I'd recommend the Prusa or the Bamboo. Okay. The other thing that's important about when you pick a 3D printer, I think I've got a slide for this, but do you see how this one has two threaded rods on it? Okay, that's called a dual rod Z-axis. The cheaper printers only have one rod for moving that gantry up and down, and you might have balance issues. It may not go up like straight. It might come up like this if it isn't, well bolted in place. If that makes any sense. So try to get a printer that has dual Z rods so everything stays nice and square within the printer. I've actually bought two Enders on the sale at Micro Center, and I sent the first one back because I couldn't get that thing to stay square with that one rod. And the second Ender I returned and got another one. Because the manufacturing is so shoddy on them, you can get pretty crappy, shoddy results. There's wheels that move it up and down on the gantry, and they had nicks on it. It would just keep bumping because it wasn't smooth. So if I had a struggle getting quality stuff, but Enders are vastly popular. So they're not. I'm not trying to diss it too much, but I had a pretty frustrating experience with them. Again, if you're wanting to get into some 3D printing, but you don't want to get a 3D printer, try to find a local makerspace where you live, okay? Because they have them and they'll let you use them. And you can download a 3D printed part and take it over there, and they'll show you how to work the printer, and you can print it and take it home. And you'll meet all sorts of people that are into this kind of stuff, and and they'll help you with things. So in this area, okay, they have other tools too. Makerspaces typically have woodworking, metalworking tools, 3D printers. If you need to do laser cutting for some of the stuff in the hobby, which is pretty handy, laser cutting is actually super easy to use. It's way easier to use than the 3D printers. They usually have them. They'll teach classes and workshops. But more importantly, you build friendships with people. You build a community, and you start building these friendships where you can help them with something, they can help you with something. Okay. So in this area. Whoops, how did that happen? Okay. If you're near Columbus, I think the biggest one in this area is called the Columbus Idea Foundry. It's a huge facility, 65,000 square feet. You got to pay for a membership to use all the cool tools in there. Okay, it's $85 a month. But they have everything. If you're looking for a water jet cutter for cutting metal, they've got it. You're looking for a CNC cutter that will cut 4x8 pieces of wood, you know, they've got it. And you know, they teach you how to use this stuff. So that's, I think, the biggest one in this area if you want to go and explore. I'm sure they'll give you like a free tour. They do. Check it out.
They do.
They do.
They do?
Yeah.
Does anybody live closer to the Akron-Cleveland area? Or is it just me? Okay. What you guys want to do, up in Cleveland at Case Western Reserve, they have a place called ThinkBox. Have you heard of them? Okay. Have you been there? You got to go. It's the biggest academic makerspace in the world. And it's open to the public and free use. So basically, you go there, they'll teach you how to use the machines, or you learn it and they help you. You got to bring your own materials. They don't, unless you buy materials there, but the machines are free to use. It's an 8-story building of makerspace. I mean, they've got everything. Full
It's on
workshop.
campus?
Huh?
It's on campus?
Yeah. You can call them and get like a free tour, but you just go up and show up and say, I'd like to use this machine, and they'll help you with it. Full wood shop, full metal shop, everything. So it is an awesome place to go if you need things done. That's Idea Foundry. We also have the Columbus Makerspace. I'm not sure where that is other than being in Columbus, but they have laser cutters, 3D printers. There's websites down there I've got in on the link down there. Libraries often have makerspaces. So if you don't have something big like that to go to, or you just want to go check out something about being a membership, find out if your library has a 3D printing room. Some of them do. Okay, so there's 2 of them here, Marion Public Library and so virtual. Okay, so I'm just wrapping up here because I'm surprised I'm covering all this in an hour.
Take your time, Tom.
You had time?
Yeah, take your time.
Okay, cool. So this is a little technical stuff just to help you with getting used to a 3D printer. There's common sore points with 3D printing that make it very frustrating to use. So these are the ones that I've run into that might help you guys out too. Trying to get these things to work well. Okay. Nozzle size. The hole where the filament comes out is a certain size. For most 3D printers, that's 0.4 millimeters, right? That controls how much plastic comes out the nozzle and how thick your layers are. Okay. So if you need things to print faster, buy a nozzle with a bigger hole. Right. Someone's going to say it. I think it'd be you. Yeah, size sort of matters because when you get to a bigger nozzle, the plastic has to flow through faster through your extruder, right? And if your heater inside the nozzle, is not strong enough, it can't handle that flow, right? So like recently at the college, we got a grant money to buy what's called the Prusa XL. And it's like, yeah, this is Tim Allen home improvement for me. It's 350 millimeter build area, right? And it's a tool changer printer. So what that means is it's got 5 print heads ready to rock and roll on any print job. So if you want to print something that's 3 colors, right? You load 3 colors into the 3 print heads, and it just grabs a head, draws the blue, grabs a head, draws the green, and then I want to add some rubber to the side of that. Head number 4 is going to do that, and it does it all together. Totally awesome. But another thing you can do with those tool heads is you can get a bigger nozzle. So I can take the 0.4 nozzle out of one of the heads, and you guys can do this on any home printer. You can take the nozzle out and put in a bigger hole nozzle. So I thought I'm going to there's a 0.4 nozzle that comes with, you can buy a 0.8 nozzle for $20, right? So I bought the 0.8 nozzle, thinking that twice the plastic's coming out, so I should be able to get twice as thick layers, right? Didn't work that way. When I loaded into the Slicer software to see the time estimates for the bigger nozzle, it was only 18% faster print time. What's up with that? Well, I sent a message to Prusa, and they said the heating element on the heads can't heat the filament fast enough to let it flow enough out. So if you want to do fast printing of big things and you want to use that big nozzle to make things happen, make sure your extruder can handle the heat. Okay, there are certain types of extruders, I think one's called Volcano, where it gets real hot and it melts that plastic so it can flow fast. Does that make sense? So the nozzle size will help you print things quicker, in addition to input shaping. Those are the 2 keys to make things print fast. Get a printer that's nozzle. Yes?
So, Tom, do we believe that the slicers will compensate on that based on, how do you tell your slicers, say you're using Cura, that may not be in the configuration for the printer that you're using in Cura. So it's a trial and error thing, right?
You mean the input shaping?
Yeah, say, no, not so much input shaping, but say I change my nozzle to an 8. And obviously, your slicer took into account not to go 50% faster on the 8 millimeter nozzle.
Right.
So it didn't double the speed. It knew that it was going to take longer for that particular machine's heater to warm up.
Because I was using Prusa slicer on a Prusa
You were
property,
using Prusa.
they knew the physical properties of that printer, that's why it would just say, I just can't do it, you know? But like if you added a bigger nozzle to your printer, and you wanted to print twice the thick layers, you can tell the slicer I'm using a 0.8 nozzle,
Right.
and I know that my filament takes 200, if I'm doing an ABS, I might need 230 degrees to print that. So you tell your slicer that I'm using a 0.8 nozzle, I'm using filament that's 230 degrees, I'm ready to go, right? And I hit print. You might find that it starts building your part, but then it might start failing about a third of the way up because the filament isn't coming out hot. I don't know. The software doesn't know that your printer can't keep up with the heat.
Right.
So you can tell the software anything in the world, but the printer physically may not be able to handle it.
So that's because you were Prusa probably.
Yeah, it knew the limitations, and it made sure I wouldn't have a failure.
So like in the bamboos, they have the profile. Bamboo has its own slicer based off of, and it's got profiles. So if you say, hey, I'm using this nozzle, then it adjusts everything in the software automatically and compensates for all of that. So you don't have to do anything other than say, hey, I've switched it to a 0.08, and it knows its parameters and off it goes, just like you there. So as long as you're using the specific brand, the specific slicer that's programmed for that.
Well, you know, one of my printers is older than Tom's been printing 3D printing, so he knows.
Yeah, I've seen it.
Yeah.
Yeah, and most commonly, printers now have got excellent profiles, even in Cura,
Yeah.
that do all those adjustments. Unless you've got some esoteric one or one that's more than 10 years old. If you put any modern ender in there, it makes those adjustments too. Because there's a lot of, like you said, there's a huge community of people that do test prints and then adjust the printer profiles.
Yeah. And most people are just going to be printing small things. If you want to delve into the bigger stuff, then you have to worry about this extra stuff. But that will affect what you're buying, right? If you know you're going to be doing big stuff, make sure you have a printer that heats very well, right? And has input shaping, because you're going to need that in the end. We talked about the filament types. PLA is your best starter filament, right? We talked about the enclosure. First layer. Does anyone know what I mean by first layer?
Yeah.
All the blues, all the frustrations of 3D printing turns out to be first layer issues. Okay, and what I mean by that is the first layer that goes down is the most important, so that the plastic sticks to your bed. Okay, if the nozzle, and there's ways to make this easier. Okay, but the reason why there's an issue is if the nozzle starts extruding your plastic a little too high off the bed, right? The filament will lay on the bed, but it needs to squish into the bed a little bit to start the sticking process. So if you're just having it too high and it's just beating on your bed, it won't stick. And what will happen is during printing, it'll break loose and start shifting around your bed. Which leads to another thing that I don't think I have in the slides. 3D printers are hot devices, right? The print head gets very hot. The bed is also hot. It can get from 60 to 100 degrees Celsius, okay, to keep things sticky, to keep the printer stuck. Long prints take a long time. You might want to print something that's 8 hours, right? You might want to print, like some of those rod designs might take 10 hours, maybe 15, It's tempting to print things overnight, right? Well, it's hot. Okay, what does that tell you? It's potentially dangerous. Okay, so 3D printers are more reliable the more expensive they are. So if you buy a cheap printer and you try to run that thing overnight, you better make sure your property insurance is up. Okay, it's a pretty low chance it's going to happen, but if you look at some pictures on the internet, you do some Google image searches of 3D printer fires, it's a possibility. So I highly recommend that if you're going to print at night, try to do something to watch that thing. You know, get a camera on it, tie that camera to your dog, let it watch it overnight for you. You know, but these are tempting to run when you want to do something, then go around to the store and go buy some things while it's printing. I recommend that you always have somebody home to watch it once in a while to make sure it doesn't fail. Not just for the fire failure, but if you print something and something goes wrong where the plastic dislodges from the bed, it'll start printing in midair, like filament's coming out and there's nothing to attach it to, and it's called spaghetti mess. If you let that run for too long, that spaghetti turns into a blob. And if you let go for too long, that blob will seal up the bottom of your print head in plastic. Not fun to clean, okay, if it's cleanable. So that's why you want to watch it once in a while, okay, to see what's going on. So anyway, about the layers. Too high up is bad because it won't stick. Too far down means the nozzle is so close to the bed, when the plastic comes out of the nozzle, it'll spread, okay? And you won't have an even first layer. It'll be a thinner first layer than what you anticipated. And that actually has a cumulative effect. The next layer above will be slightly too high and it won't fuse as well because the other layer is too low. And it causes other issues. So having that first layer is critical to making sure it starts out successfully. And I'll show you some ways to help with that. The proper distance for the head, if you have to do it manually, if you have a printer that doesn't do the leveling automatically, the proper distance is 2 sheets of paper thick. So in your printer, you may have to use some screws on the bottom of the bed to adjust the balance and the closest to the print head. If you get 2 sheets of paper under that nozzle and you feel a little bit of friction, that's about right. That's about the right distance. But the best thing is you don't have to mess with that at all. You want to buy a printer that does all that automatically. Okay, we're going to talk about that in a second. Okay, the bed type is pretty important. There's many different kinds. You can get this kind of bed here is my favorite right now. This is spring sheet metal, right? And I can't demonstrate because it's currently printing, but one thing that's hard about 3D printing is it may stick so well that it's hard to get it off, right? You can't remove it, especially if you're doing very thin things. So what is it, PETG? I think. If you print some things on PETG like on the glass, it ain't coming out better. Okay, you're gonna have an issue. So there's ways you can mitigate that. But if you get a printer with a flexible print bed, when this is done printing, I can actually lift that bed right off. It's just magnetically attached right now. I can peel it off and I can bend the bed a little bit in 2 different directions, and your part will actually pop off. Most of the time, depending on what you're printing. So the flexible bed is my favorite by far. Okay, and there's a coating on this bed called PEI, which helps the plastic stick. So in this case, this is a PEI powder-coated spring sheet flexible magnetic bed. So you got all that? Okay. There's other kind of beds too. You can get a solid glass bed, and believe it or not, PLA sticks really well to that. Okay. There's the powder-coated. We talked about the rigid versus flexible. So if you get a flexible bed, that's the best. The reality is some of them have a flexible bed that's it's not the metal, it's like
Well, it's PEI, but it's aluminum.
Oh, is it? Okay, so it's still a metal of some kind.
Yes.
Yeah, okay.
But it's not flexible.
It's rigid, yeah.
But it's PEI coated.
Yeah. If you get a rigid bed and you have to use a tool to remove your thing, the tool could damage your bed, it could scratch it. In some cases we had a glass bed and our students would take a scraper and they just take chunks of glass out of that bed.
Unfortunately, they include those scrapers with every printer, and they really shouldn't.
Right, exactly, yeah. So that's why flexible is nice. You won't damage your bed as often. Okay. To make your stuff stick, we talked about the nozzle height. That's really important, right? To make sure it's perfect. But there's other things that help too. There's a special kind of glue that you buy at Staples. It's called Elmer's Disappearing Purple.
It's actually elementary school student purple glue stick.
Yes. Yeah, just the very cheap stuff, That's the disappearing purple, that's the trick. It has to be that formulation. So if you put that on the bed, like I did here, good chance it's going to stick well. If you have a properly adjusted nozzle height. Okay, so this helps, especially with the PLA. Captain tape, this orange stuff, is another trick to make it stick. Some people use painters, glue tape, but that's kind of been falling out of fashion, so people don't use it as much. I like the glue stick, the most. I'm not going to get it. Oh, hairspray. Hairspray's bad. Don't use hairspray.
I had to cut it off because my hair all stuck together.
Hairspray is not good because when you spray it on your bed, it works really well, but it also gets into other things in your printer you don't want to. So bad, it does work, but it's bad news. If you're printing with PLA, right, that beginner plastic that I recommend, that everyone starts with, you don't need any of this stuff. If you have the right nozzle distance, right, and especially if your bed is free of hand oil. When you start manipulating your bed, you get that oil on it, that's going to prevent things from sticking well. So you'll find that if you clean your bed with rubbing alcohol and you have the right nozzle distance and you're using PLA, you don't need any of this weird stuff. It'll stick pretty nicely. Okay? But if you're messing with ABS, maybe PETG, you might need some additional help to make it stick. All right?
Hodgepodge works pretty good.
Hodgepodge? I've never heard of that.
I've used water and sugar before.
I've heard of that. I've heard it works. Yeah, well, don't lick your print bed.
At one time on my ABS machine, I made a slurry of ABS and acetone and rub it on before it starts.
Yeah, that works too.
And that's what really resolved the big problem I had.
Yeah. Okay, I'm just about done. I got 2 more slides, 2 or 3 more slides. Okay, remember I talked about that distance, the starting height? Some printers have to do that manually, so you have to adjust screws on the bottom of your print bed to get that perfect distance. And as you print with it, as you remove a part from it, it might mess up that balance. So every about 5 prints, you might have to readjust the balance, which is a real pain. There's my bed. And it's warm right now, but say goodness for anything easier. But some printers, instead of the manual screws, they have what's called a probe, where it has like a little sensor that actually touches the bed to figure out where the height should be. Right? So every time you print, the printer will actually go around and probe the bed for the overall balance and the distance. Okay? So those are nice. This particular one uses a magnetic probe, so when it gets closer to the metal bed, it knows its distance. Okay? So you want to get a printer that has some kind of probing capability to figure out your balance or the distance. And I'll just leave it at that.
Tom, the real reason you want that is, despite looking at that with your naked eye, even one that's solid plate glass, there is no flat print bed ever been invented.
Right.
And so the probe, the wheels balance your 3 dimensions only on the corners. You could still have a dip in the middle of your bed.
Yep.
And so the probe thing literally maps your bed and will adjust that first layer so that, let's say you've got a little dip in a spot on the first layer, it will deposit more filament to fill that dip so that then from layer 2 up, everything is perfect.
Right. I was going to skip saying it because it was complicated. I'm glad you brought it up. So that's good. So the probe will figure out if your bed is not perfectly flat and compensate. So probes are good. You want to get probe, right? You want to get a printer with 2 lead screws to the Z-axis. That keeps things square. That's also important. If you can get a printer that has what's called a load cell sensor, okay, because our new Prusa has it, and I love it. What it is the filament coming out of the nozzle, the extruder itself on the newer printers have a microprocessor in them. They have sensors in them. They generate data. And so if it has a load cell sensor, that means when the plastic's squishing into the bed, it can measure the amount of squish. Okay, so it knows not just the physical distance of the probe, but it knows whether or not it's squishing at just the right pressure. So that means it's super guaranteed to work the first time. That makes sense?
Wow.
So load cell sensors is one of the latest things that are pretty awesome. What does the bamboo have? Do you know? I can't remember.
So it's in the nozzle itself, and it does every print. It goes 12 times, and it hits the bed.
That's probably magnetic or
Yeah.
it senses the steel of the bed.
Yeah, it's the nozzle itself that
Yeah.
does. It'll pop, 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 and it'll move on to the next one. Pop, 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 and it does 12 times around the bed.
Yeah.
And it'll go. Yeah.
Okay. I think it has LiDAR. Believe it or not.
So the super high-end one,
Has
like
LiDAR.
yeah.
Go figure.
All that does is it checks for spaghetti on the first layer.
Oh, see, things are messing up.
If you lost adhesion immediately.
Yeah, it's a spaghetti detection thing on those, and so it'll stop your print. But now you can, if you're printing, and actually it was a high-end one had it. I have P1S's, which is the middle of the road, which is $699, which I think is a great deal for those things. But now they have in our software on my phone, for example, if I'm printing, because everything's done, you can do it from your computer, do it from your phone, you can just send it straight to the printer, you don't have to miss the SD cards or anything like that. And let's say I'm printing 12 objects, 12 of these things on the plate, and one of them spaghettis, and I see that one spaghetti, I can go on my phone and say, skip that one, and it will, for the rest of the print, skip the bad one, and then that way the rest of them you can.
Well, we're doing multi-object.
Yeah.
Because
Yeah.
that's
nice.
If you print lots of things, like suppose you want to print 20 clips, right, on your print bed because it'll hold 20 prints, there might be a chance that 1 out of 20 might bump loose off the bed, and then it'll print the other 19, but it's still spitting out filament for the first one that messed up. So it'll still keep printing all your other clips, but the one spot will keep building up this spaghetti pile of filament that could pick up and drop off your good parts. So there's things that are helping with that trick if you're doing multiple parts.
Yeah, it's really nice, because like, especially with the corner ones that tend to warp or lift or whatever, if you have a full plate, then, you know, one of them's spaghetti, it's a 5-hour print, and you're halfway through, and one of them's spaghettis, and now you've lost all of them, now you can skip that one and just, it'll know to bypass it, so you don't really have to print. Saves a lot of filament that way.
I think I've covered almost everything. I'm done, I'm sorry that I went over it. But if you want to know more, again, that all3dp.com, excellent website. Everything 3D printing related, I love that.
That is a good site.
Yeah, go to Facebook, there's a lot of groups. If you buy a Creality printer, go to the Creality support page. It has 10,000 people there waiting to answer all your questions. You know, that helps a lot too. Go to your local makerspace. Okay? Yeah.
Okay, Tom, since you are on the cusp of all the information at school, I've got this piece right here. It matches another piece that I got. And, you know, I know Creality has one, but are there any reasonable or open source scanning programs, devices that I could scan that into a model?
Yes, and it's expensive.
That's right, it's something that's,
Yeah,
that's not crazy, because, I mean, I think that's one of the things that is making it hard for a lot of people is, but I don't want to spend 12 hours designing a 50-cent part.
Right. 3D scanning is, in my opinion, not mature enough in the consumer market. We bought like a $2,000 scanner for the college, you know, and you just put your object on a bed and it scans it, rotates it and scans it. It doesn't do small things very well. And then I had a friend just 2 weeks ago, he wanted to do toy soldiers. He had some vintage metal, or actually lead soldiers. He was looking at them as I walked in. That he wanted to make more of them because he can't get them anymore. So we couldn't use our scanner because it broke. So we took it up to ThinkBox and we did it on their $20,000 you take an arm and it's like a gun, you actually move it all around your object and it scans it on the fly, and it was disappointing. So I think you can there are scanners that are pretty affordable, within $500 to $1,500 range, that say they do quality, and maybe if you fight them enough, they will. But it's been my experience for small things, it's going to be a struggle. So something like that lid, it's worth your while to learn CAD and to make it, because it's surprisingly easier than you think.
Well, yeah, I mean, that was an example. I'm just,
Or
you know.
what you could do is you could say, I've got this shape, and someone in one of these support groups, or someone from this group, you send it to us, we'll design it, and then we'll send it back with an STL
There you go.
for food.
Your phones can do it too.
So any
Phones
question
with
about
LiDAR
it?
can-
Yeah, that's what I
There's an
thought
app
I had
called
seen Apple.
Polycam, I think, but it's kind of pricey. I think it's like $100 a year. Well, I
Yeah,
don't
go
know,
ahead.
it's expensive.
So just so folks know, if you decide to get into this and you aren't into it yet, you're going to run into something that he didn't talk about, is that there are actually two consumer types of printing. Everything Tom's been talking about and demonstrating is called FDM, Filament Deposit Modeling, I believe it stands for.
Fused disposition. Fused disposition. I can't pronounce it. Fused disposition modeling.
Oh, okay.
Yeah, I can say it, really.
And one of the things you'll hear, some people are trying to print like ultra fine, production machinist quality stuff. I don't care what you pick up or what printer prints it, you'll be able to tell if it's FDM printed because just run your fingernail on it.
Yeah.
But it's still, for what you get, some of the stuff is stunningly good, and for most of our uses, who cares? Because but the other type of printers that you can buy, that if you you go to the store, so you don't get confused, is somebody will talk about, oh, well, you should buy a resin printer. Well, resin printers basically are a whole nother animal. While they, again, print a layer at a time, how it does it will blow your mind. It's sort of like the liquid Terminator guy. You literally take this vat, and it's got liquid plastic at room temperature in it, and it actually draws the figure out. The way it does it is, there's this bed that floats in there, and there is literally UV light that gets sprayed on just that layer, and it literally is, if you watch it, it pulls the image out of the plastic, just like the T2 Terminator comes out of the pool. That's what it looks like.
That was the first 3D printer
I know.
invented, that type. And resin printers are good if you want extreme detail. So if you're making,
Exactly.
like you're a board gamer and you want to make models, you know, or if you're making jewelry, you know, tiny things, it's excellent. It does super high resolution. But resin, unless you buy tough resin, like it's not very strong what you make, unless you buy specially formulated. But the resin printers are a mess because they're messy. You got to deal with the liquid resin bottles that you pour into a tray. You got to wear gloves to make sure you don't get it on your hands because it's toxic.
Yep.
When you take it out, you've got to clean all that wet resin off with alcohol. You got to let it cure with UV light. I mean, if you're into like miniatures and things, they're excellent, but they're not easy to use because they take more work to use. They're easy to use, but they take a lot more processing work.
They're great, in my opinion, for models, like you said.
Yeah.
If you're modeling anything, they're actually what you get out of them is spectacular. But for Christmas lighting, I can't imagine anybody needing a resin print.
Yeah, but again, the whole thing about 3D printing, it makes your crazy ideas possible. You might have a need for something, and you can't make it because you don't have the skills for woodworking, metalworking. You can make stuff. It's really liberating. If you have a need for something, and you're willing to learn a little bit of CAD, you know, it's pretty awesome when you figure out, I can make this, and I can make this work. So, yeah.
What's your thoughts or the group's thoughts on the used machine?
A used printer?
Yeah.
Generally speaking, they hold up pretty well. We've had some for 10 years, and they hold up pretty well. They do break. I mean, they do have things that wear out. But in general, I think it's okay if you're getting it from a trustworthy source, and they tell you that it's working okay, and you trust them. Parts that can wear out on a 3D printer, it's hard to tell.
It's not much.
Like the belts can get a little saggy, but you can tighten them or replace them. I'd say they're pretty reliable. But if you get a pretty low-end printer, they're going to put low-end parts in it, you know, that might not be high enough quality. Like these cement screws on cheaper printers may be not perfectly vertical, or they might, you know what I'm saying? Just they choose linear rails. Some printers work with linear rails from back and forth. You get those from China, and they're crap. You know, some of the cheap printers might have cheap linear rails to move things around. So things like that. So I would, they're so cheap nowadays, I just get new and not have to deal with anyone else's headaches. So, yeah, you can have mine.
And then, one other thing, I've got 12 pixel pushers sitting on my box up here. Please just come take one. If you don't have pixel pusher and if you don't know what they're used for,
Pixel strip.
you print one of these if you use Coro strips. I know a lot of people know what the black Coro strips are. You just slide them into this jig and pop your pixel, bam, bam. It allows you to not ruin your hands to insert bullet pixels into Coro strips. But at any rate, pixel pushers, please come take these. I don't need a dozen of them.
Pardon? You don't need to?